Hello everyone, my name is Rajan Sharma. I work as principal architect and most of my work is around cloud architecture, Kubernetes, platform engineering, DevOps, security, and product systems. In real projects, I have seen one common pattern again and again. Teams start using Kubernetes with a lot of excitement. And at the beginning, anything feels powerful, like you can deploy anything, you can scale anything, you can expose services, you can configure resources. But after some time, the same flexibility start creating problems. Every team deploy in a different way. One team have no resource limit, one team using the latest image tag only, one team expose a service publicly by mistake, one team ask for cluster admin because something is not working, and one thing copy old YAML from another service and change only the image name. And then when production breaks, someone says, but it worked in that. And that sentence sounds simple, but in the production it's become expensive. Because the real issue is not only the something is working in the dev. The real problem is why did our platform allow unsafe choices so easily? So this is what is this video is about. We are going to talk about how to stop giving every team raw Kubernetes, instead build a Kubernetes platform that team can actually use. Not a platform that show developer down, not a platform full of approval gates. It's just a platform that becomes a ticket queue. But a platform where developers can move fast and production can be still stay safe. In this video, we will cover safe defaults, clear policies, reusable templates, admin control, golden path, RBAC, visibility, and control exceptions. The goal is simple. The safest path should also be the fastest path. So let's start with simple first. Mistake many teams make. They think working YAML means production-ready Kubernetes. Many teams confuse working YAML with production-ready Kubernetes. A deployment can be valid, a pod can be running, a service can be reachable, a Helm chart can install successfully, but that doesn't mean the workload is ready for the production. Production asks harder questions like, is it secure? Can we observe it? Can it recover? Can it roll back? Does it have an owner? Can it can it scale safely? Can one team accidentally affect another team? Kubectl apply is not the finish line. It is only the beginning. Deployable means the workload starts. Operatable means the workload can be trusted when something goes wrong. So this is the difference. This is the difference platform engineering must solve. When something fail in production, the easy reaction is blame to the person who made changes. But that is usually not the full truth. The better question is this: why did the platform allow the risky things so easily? If a service have known that platform designing gap, if every team deploys differently, that is a platform design gap. If public ingress can be created accidentally, that's a design gap. If a privileged part can run without review, that is again a platform design gap. Kubernetes gave us a powerful building blocks, but building blocks are not the same as the platform. A platform gives safe direction, so that is not only a developer problem. This is not only a Kubernetes problem. This is platform design problem. Raw Kubernetes may work for one team, but when 20, 50 or 100 teams uses the same platform, raw Kubernetes become dangerous. Every team start making its own decisions, different labels, different resources limit, different ingress patterns, different security context, different rollout strategies, different monitoring setups. The problem is not the everything is completely wrong. The problem is that many things are almost correct, and almost correct is where production incidents live. So the job of the platform team is not to manually review every YAML file forever. The job is to build reusable safely into the platform. Most developers do not want, wake up excited to maintain hundreds of lines of the Kubernetes YAML. They want to ship services. They want a clear path. They want to know why and what they need to provide. They want to know what the platform handles for them. They want quick feedback when something is wrong. They want to debug without asking five different terms. They want rollback when something breaks. So, if our platform forces every developer to become an expert in every Kubernetes details, we are not helping them. We are transferring platform complexity to the application teams. A good platform does not expose every possible Kubernetes opinion. A good platform exposes the right choice and hides unnecessary complexity. The word guardrail is important. Many developers hear guardrails and think another blocker, another approval, another ticket, and another person saying no. That happens when team design guardrails like gates. A gate says no, you cannot go. But a true guardrail say you can go fast but do not fall off the road. A bad guardrails may say denied, but a better guardrail say denied because resources requests are missing. A great guardrail say that denied because resources requests are missing. Use resources runtime size, small, medium, or large in the approved tablet. Now the developer is not blocked, the developer is guided. This is a difference between control and enablement. If every deployment need a platform engineer, then we have not built a platform, we have built a queue. And to be honest, the developers hate queues. Platform engineers also hate queues. The real mindset is different. Platform teams create pivot roads that set safe defaults. They define clear boundaries, they build reusable templates, they give team a trust path to the production. The goal is not come to us every time you want to deploy. The goal is we already built the safest and the fastest path. Use it and move. This is platform engineering. Here's the main model. A good Kubernetes platform needs 5 guardrail layers: default, policies, templates, visibility, and the last is exceptions. Defaults are what teams get automatically. Policies are what the platform will not allow. Templates are how teams create services consistently. Visibility is how everyone understands what is running. And exceptions are how teams safely break rules when there is a valid reason. This is the important because guardrails are not only admission policies. A real guardrail is a complete platform experience. It starts before deployment, it continues during deployment, and it remains useful after production. Most teams start by writing rules, but the better starting point is defaults. If the defaults is already safe, you need fewer rules. If every new service automatically gets owner label, fewer services are unknown. If every service's templates include props, few services and invisible to health checks. If every runtime size map to approved resources limit, fewer workloads create noisy neighbors issues. If um, observability is included by default, fewer terms are building during incidents. Developers should not have to remember 25 Kubernetes best practice just to deploy a normal service. The platform should carry that responsibility. Ruler says, remember this. Defaults say you already handle this for you and this is much better experience. Every service need a minimum contract, not 50 page of the documentation. Just the basic information needed to operate it later. So what it is? Um, who owns the service? What identity does it run as? What resources profile does it need? How do we know it is healthy? how it is deployed, how do we observe it, how do we roll it back, and what data or deployment risk does it carry. It protects everyone. It helps developers because exceptions are clear. It helps platform team because governance is consistent, and it helps SREs because incidents incident response become easier. So missing ownership become confusion. Missing props become slow recovery. Missing observability become guessing. Missing rollback become panic. This is why every service need a minimum contract. Policy as code is platform memory. Every experienced platform team has seen that same mistake again and again. No resources limit, latest image tag, privileged containers, missing owner label, wrong registry or registry have some issues, risky ingress host path values over permissive access. If human reviews all of this manually, it does not scale. Humans get tired, humans miss things, humans are inconsistent. So policy as code make the decision repeatable. It turns production lessons into an automatic check. The platform does not need to keep saying the same thing to every pull request. The policy say it consistently. This is where policy as code is not just the security, it is a platform memory. Admission control is where guardrails become real. Before admission control, a rule may be written in the document, a standard may exist in the MIDI notes, a best practice may be mentioned in the reviews, but admission control is the moment Kubernetes say this is allowed or this is not allowed. This exact tool can vary, like the OP gatekeepers, Kyvernio, validating admission policies, port security, admissions, custom webhooks. So the principle matters more than tool, but put the guardrails close to where the risk become real. Like if a privileged pod is already running, the policy is late. If a privileged ingress is already exposed, the policy is late. If a risky workload is already in the production, the policy is late. Admission control helps prevent risk before it becomes live. A deny message is a part of developer experience. Many teams forget this. A policy that say only deny may be technically correct but practically useless because the developer now have questions. Why was this denied? Why should I change? Where is the example? Which value is missing? Who do I contact? A bad policy explains the reason. A great policy explains the reason and gives the fix. Every policy should answer three questions. What failed? Why does it matter? And how to fix it? If your policy cannot answer these questions, it will create friction. Good governance should guide, not confuse. This is the golden path. And a golden path is not a document. A golden path is an experience. It shows the developer exactly how to create, build, deploy, observe, and roll back a service. The most important rule is this: the golden path must be faster than the custom path. If the approved path is slower than, teams will definitely going to avoid this. If the approved path requires 5 tickets and the custom path require one command, teams will use that command. So the golden path must feel like the fast lane. Create services from template, fill simple values, push to Git, pipeline builds image, GitOps deploy to the dev, policies validate the changes, dashboard and alerts are created, promotion path is clear, rollback is available. This is what the developers need. They do not want raw Kubernetes. They want a safe and fast path to ship services. Helm is powerful, but it can become a dumping ground. Sometimes platform team expose everything in the value file and then the developer sees almost like 150 options. This is not simplification. It is just what we did is move complexity from Kubernetes ML into the helm values. A better model is intent based. The developers say, this is my service, this is my owner, this is my runtime size, this is in, internal or public, that needs standard observability. That platform translate that intent into safe Kubernetes. Your values.yaml is a user interface. Your templates is a user interface. Your error message is a user interface. Your dashboard is a user interface. So every touch point shape whether developers trust the platform. Dev, QA, staging, and production should not be the same playground. Developer need freedom in the lower environment. They need to test, they need to fail safely, they need to learn fast. But production needs stronger boundaries like different tarbag, different policy strategies, different secrets, different ingress control, different quotas, different deployment rules. This is not about blocking developer. It is about matching control to the risk. The closer you get to the real user, the stronger the guardrails should become. This is the practical platform model. Temporary admin access is one of the most permanent risks in the technology. We say just give admin for today, then today become the week become the quarter, and one day during an audit, everyone asks, why this person still have access? RPAC should match responsibility. A developer working in one namespace should not need cluster-wide admin access. A support engineer may need read access across environments, but not write access everywhere. And a platform engineer may need elevated access, but it should be audible. Production break glass across should exist, but it should be controlled. Good access design means least privilege, namespace ownership, time bound elevation, break glass path, audit trails, and GitOps first changes. Enough access to move fast, not enough access to accidentally damage the platform. If developers are fighting the platform team should know. If policies are failing repeatedly, this is a signal. If exceptions requests are increasing, that is again a signal. If onboarding takes too long, that is a signal. If deployments fail because of unclear rule, that is a signal. Without visibility, platform teams only hear the loudest complaints. With visibility, they see patterns. A platform team should measure not only control, but also friction. Policy violation, exception request, deployment failure response, service missing honors, resources waste, risky workload, time to onboard. These signals help platform team improve the product. Instead of saying developers are not following standards, we can ask where the platform experience is breaking. This is much better conversation. Now, let's make this practical. Scenario 1, missing resources limits. A team deploy a service without proper request and limits. Everything works fine in testing. The pod start, the service respond, the deployment looks successful. Then production traffic increase. One workload start consuming too much CPU or memory. Other workload on the same node get affected. Now, this is no longer one team's issue. This is a platform stability issue. The guardrail response should include default profiles, require resource and the limit, namespace quotas, resources dashboard, and an exception workflow for the special workloads. Resources limits are not YAML decorations, they are platform safety. Scenario 2, risky ingress. A service accidentally become internet facing. This is serious because exposing mistake can become security incidents very quickly. Sometimes this happen because someone copied an ingress from another service. Sometimes the wrong ingress class is used. Sometimes the difference between internal and public expose is unclear. The platform should make the platform should make accidental public exposure difficult, not impossible when needed. Difficult accidentally. Guardrails that include approved ingress classes, explicit exposure declaration, blocking public ingress by default, security review for the external exposure, and standard TLS and WAF patterns. The developer should not have to guess whether a service is internal or public. The platform should ask for the exposure should ask for the exposed internet and apply the correct platform. Scenario 3, with the privileged container. Sometimes a workload requests privilege mode. Maybe there is a valid reason, but often it copied from somewhere or added during troubleshooting or used because something did not work the first time. Privileged containers carry serious risk. They weaken isolation and increase blast radius. So the guardrail should be stronger. Use port security administration, use policy add code required, exception approval, make the waiver time bound, keep audit visibility. Sometime some control should be exist for flexible. Some control should be hard boundaries, and the platform team must know the difference. There's another scenario, the small change. That is my favorite. You know this line, sir, just a small change. Small change in Kubernetes like small spice in India. It have its own definition. And a small Helm value change, a small config update, or a small replica change, maybe a small ingress annotation or a small environment variable. And sudden production is doing something very creative. Most incidents start as a normal change, so the platform response should be GitOps, pull request check, different visibility, progressive delivery, rollback automation, and change history connected to alerts. The goal is not to stop change. The goal is to make change safer. And do not jump directly to the 5 level. Every organization wants a self-service platform, but maturity have stages. Level 1 is manual review. Everything depends on experts. Level 2 is document standards. Team know what good looks like. And then level 3 is automated check, common mistake and caught early. And then level 4 is the golden path, safe deployment because we need to make it easy. And then the level 5 is self-service platform. Team move fast with built-in governance, but level 5 without level 2 and 3 become chaos with a nice UI. Build maturity step by step. Start with repeated production pain. Turn the pain into default policies, template, dashboard, and exception path. That is the practical way. Now let's talk about what not to do. Do not create too many hard gates too early. Do not write policy with unclear message. Do not expose raw complexity to developer. Do not build a platform nobody asked for. Do not treat every exception as failure. Do not measure control while ignoring developer friction. A platform can be secure and still fail. A platform can be technically correct and still fail. A platform can have beautiful architecture and still fail. Why? Because nobody wants to use it. Internal platform need adoption. Adoption comes from trust. And trust comes from usefulness. Unusefulness comes from nowhere. So the usefulness comes from solving a real problem. The better approach is simple. Start small, pick recurring production pain, convert it into a guardrail. Missing labels become required metadata policy. Repetitive resources issue become a default profile. Manual deployments become GitOps workflow, and risky public expose become Ingress guardrails. Debugging confusions because observability defaults. Do not start with giant transformation. Start with the top 5 mistakes you learned repeat. First, fix those. That is how platform engineering becomes practical, not by creating a huge platform vision document, but by reproducing real pain step by step. If you remember only one model from this video, remember this. Developer friendly Kubernetes guardrails need 5 things: safe defaults, clear policies, reusable templates, operational visibility, controlled exceptions. Defaults make it the right thing automatic. Policies prevent dangerous behavior. Templates make consistency repeatable. Visibility shows whether the platform is working. Exceptions keep the system practical. And this is how platform teams balance speed and safety. This is how we move from raw Kubernetes to the real problem. The best Kubernetes platform does not slow teams down. It removes dangerous choices teams should not repeat every day. Developer should not repetitively decide, should I add resource limit? Should I add props? Should I use latest tags? Should this be public? Should this container be privileged? Should this service have an owner? The platform should make the safe answer the default answer. Platform engineering is not about controlling developers. It is about removing the dangerous choices they should never have to make alone. If developers feel blocked, we build gates. If developers feel faster and safe, we build a platform. Thank you.